The holiday season is upon us, and as we are desperately trying to avoid the Christmas ads, at least here anyway, let's look into SQL queries and how they can perform for you. Today we're going to look at a very simple subject, which is how to get the most out of a query. Now, honestly, most people write a query and they're done. They don't think too much more about it. And that's a bit of a failing, really, because you can get so much more out of your query, and depending on your data structure, it's easier to get something out of the query than it is to get a new data structure. So, as an example, you might have some limits as to what you can put indexes on due to other queries. So, let's look specifically here at our queries. We're going to put the statistics on for the time and the I/O so that we can measure each one. I'm going to clear the buffer in between. And our first query is going to check for the value 6 organizational unit, and it's going to do a union with the same table with a date range. And then we have a common table expression, which basically performs exactly the same. And last but not least, we have our join query, which is going to use an OR statement to get the same results out of the same table. Now, probably some of you can take a guess at how this is going to perform, but if not, we're going to run it anyway. And again, this will vary depending on how your data structure works. Sometimes the other queries will work better for you, and that's why it's important to test. So if we go ahead and look at our query now, we can see that we have the same number of rows returned for each, and the time for each query is slightly different. But we can see the most performant query is the one with the least I/O reads. And that generally tends to be the case across the board. Whenever you're developing a query, the one that has the lowest number of physical reads or logical reads tends to result in the fastest query time, unless you have other bottlenecks such as group by or sort, where it becomes a CPU bottleneck. So with that in mind, let's go ahead and now take our join query and again apply similar logic to it and say, okay, well, you can have more than one type of join. So let's look at a join loop and a join inner join and just a regular join and see what happens. So we have the 3 types specified. We've got the results for all 3, which are the same, but we have some very significant differences in time. And now it's hardly surprising, I'm sure, to most of you that the nested loop didn't do too well on this. And again, it really does depend on your scenario. There are occasions when that will be the best. But overall, you can see in general, the best result was just actually our regular join at the bottom. And we can run it again to prove the point that yes, it's still the best out of the bunch. It wasn't anything to do with just pure random luck. So keep that in mind when building queries, that the best performance sometimes comes from testing alternate versions of it. Now, the last thing I want to touch on here is, well, we've got our join, we've got realized that this is probably the best query we're going to get, but we can go one step further. We're only actually interested in 3 columns. So if we just specify those 3 columns instead of the star, can we go from the 500 milliseconds down? And the answer is yes, we can, to just under 400. We're down to 300 milliseconds. And we can consistently run it to prove a point, proving that select star is still the slowest. Please do not do select star.